morning everyone. Today we are going to see operating system unit 2 session 16. In the previous topic we have studied the concept multi-level queue and multi-level feedback scheduling. In today's concept we will study about the threads. So threads are contained inside the process. So whenever the process comes for execution, inside that only the threads are contained, and whatever the resources are allocated to the process, especially the memory, whatever the memory is allocated to the process, the same memory will be used by the threads, and there can be more number of threads inside a single process. So let us see what are the threads. A thread is a flow of execution through the process code with its own program counter that keeps track of which instruction to execute next. So thread is a flow of execution within the process, and it keeps track what should be executed inside a process. Thread provides a way to improve application performance through parallelism. So threads are included inside the process to improve the application, and the process and the task can be done simultaneously, and the process can get executed fast. Threads represent a software approach to improving performance of operating system. Definition. Another definition of thread. A thread is contained inside a process, and different threads in the same process share some resources, mostly the memory, while different processes do not. So as I told you, processes, now this is a process, and inside a process you can have more than one threads, and whatever the resources are allocated to this process, whatever the memory is allocated to the process, the same memory will be used by these resources, and it will execute the task simultaneously with the other threads. Threads are mechanisms that permit an application to perform multiple tasks concurrently. So it is one mechanism that permits application to perform multiple tasks simultaneously. Thread is a basic unit of CPU utilization. So CPU must be utilized properly, and it keeps records like thread ID. So how many threads are generated inside a process? Thread ID will be given. Program counter, which part of that process it is executing, that record will be kept in that. Register set, which register it is using, and the stack. A single program can contain multiple threads. A thread share with other threads belonging to the same process. So a single program can contain multiple threads. That is, in single process you can have multiple threads and they share the same resources. Process versus thread. Now what is the difference between process and thread? See, process are like, for example, you want to work on MS Office. So when you are working on the MS Office, that is Microsoft Word. So when you open the Microsoft Word, then it is one process. So for that Microsoft Word, some resources allocated, some memory is allocated. Whenever that process is created, Microsoft Word, some memory is allocated to that. At the beginning, the same memory will be used by the threads. So thread is what? So when you are working on the process, Microsoft Word, you generate multiple threads. Like if you want to put the border to the page, so one thread will put the border to the page, and one thread will put the header and footer to the pages, one thread will apply the colors, one thread will do the formatting. So many threads are generated in the Microsoft Word. So this all together threads works inside a process to make your application fast, and they work concurrently. Simultaneously they can work, and they can make work easy. Threads are used for small tasks within the processes, and as I told you, small tasks when applying header and footer or pages and borders. So these are the small tasks within the process. And the main process is called as heavyweight process. Basically the execution of applications. threads within the same process share the same address space will be allocated, same memory, same resources will be allocated to the threads, whereas different processes do not. So if it is a different process, then different resource, different address space will be there. But threads will be having the same address space as that of processes. So there are two types of threads, single thread and multi-thread. So single thread has single thread of control. It allows the process to perform only one task at a time. So inside a process, only one thread will be generated, and that one thread can do one task at a time inside the process. Multiprocess has many threads inside a process and simultaneously execution of different tasks. So inside a process, single process, it can generate multiple threads and simultaneously it will execute the task. This is the diagram of single thread process where only one thread will be generated and it will use all the resources of that process which is allocated to that single process. This is a multi-threaded process and multiple threads will get generated and they use the same resources which is allocated to the process. So these are the various operating system. In the MS-DOS operating system, we have only single thread. So one process, one thread is generated. And in Java runtime environment, there is one process, multiple threads. Whereas in old Unix, we find out multiple processes, one thread per process. There are multiple processes, but in a multiple processes, only one thread is generated. And in Windows and today's latest Linux has multiple processes and multiple threads inside it. Multiple processes and multiple threads inside it. Example. See now this is the example of single thread and multi-thread. So whenever we are printing any document through the MS Word, then first of all, it is going to take the input and then it is going to print. So it is doing now in today's printout, if you see, it is doing the task simultaneously. It is taking the input at the same time as well as it is printing at the same time. So earlier systems were based on single thread. That is, when you give the file for printing, it is either going to print or it is either going to take input. So after taking input, it is going to print, and after printing again it is going to take print. Means at a time it was doing only one task, either taking the input or printing it. But in today's latest system, we find out that both processes are done at a time. It is taking the input at the same time it is printing the document. So because of multiple threads, one thread will accept the input and another thread will print it. So they work simultaneously. So this is the difference between single thread and multiple thread. So printing and responding to the user input at the same time would not be possible in a single threaded application. Another example, when you double click the Microsoft Word icon, you start a process that runs Word. So as I told you, when you are working on the Microsoft Word, it is a process. A thread is a path of execution within a process. So whatever you do inside the process, it is a thread. Also, process can contain multiple threads. So when you start Word, the operating system creates a process and begins executing the primary thread of that process. This is the same the example which I told you in the beginning. So these are some of the characteristics of the threads or the features of the threads. Responsiveness. So the interactive application can delegate background functions to a thread and keep running. So there is a response from the thread which keeps on running. Resource sharing. Several different threads can access the same address space. So whatever the memory, whatever the resources are allocated to a particular process, it uses the same resources and address space. Economy, allocating memory and new processes is costly. Threads are much cheaper to initiate. So if you keep on generating like this way new processes for every task, then obviously it is going to be very costly. Like in a MS Word, if you want to apply the header footer, if you create another process, and if you want to apply pages and borders, if you're creating another process, then it is going to be costly. For every process it is allocating different memory, it is going to be costly. So thread is the best option and much cheaper. It uses the same resources which are allocated to the process. Scalability, use threads to take advantage of multiprocessor architecture. So it works like a multiprocessor architecture. Because of thread, we feel that it is a multiprocessor architecture. User and kernel level threads. So user threads are generated in the user space of the operating system, and kernel threads are generated in the kernel of the operating system. So there is an interaction between the user thread and the kernel thread to execute any task or any application. First we'll see kernel thread. All thread operations are implemented in the kernel, and the operating system schedules all threads in the system. So whenever the task is to be executed, all threads will be generated in the kernel, and the execution happens through this thread. Operating system managed threads are called kernel level threads or lightweight processes. The kernel has a thread table that keeps track of all threads in the system. So whenever any application has to be executed, in the kernel the threads will be created, and inside the kernel it maintains one table which will keep all tracks of the thread, a particular thread, what it is doing, and what this all information will be tracked. So examples of the system which have kernel threads which are operated on kernel threads generation: Windows 95, 98. These were the systems, operating system. Solaris. So these are the few operating systems which operates on kernel thread. Advantages of kernel thread is kernel can simultaneously schedule multiple threads from the same process on the multiple process. So advantage is that a kernel can schedule multiple threads from the same process. If one thread is blocked, the kernel can schedule another thread of the same process. So due to reasons, if the threads are blocked and not able to perform, then it will generate another threads. Kernel routines themselves can be multi-threaded. Disadvantage is kernel threads are generally slower to create and manage than the user thread. So kernel threads, to generate it inside the kernel, somewhat it is going to take time compared to the user threads. And then you need to transfer of control from one thread to another thread within the same process requires a mode switch to the kernel. So switching from user to kernel by using the same kernel threads. So this process is complicated and takes too much time and makes system little bit slow. Next is user level threads. User level threads are small and fast, which are generated inside the user space. Each thread is represented by a program control register, stack, etc. Creating a new thread, switching between threads, synchronizing threads are done through a system call or procedure call. So in user level threads, all threads are generated in the user space, and synchronization, switching and communication happens with the kernel through the help of the system call or procedure call. So user level threads are managed entirely by the runtime system that is called user level library. So this is very important in the user level space. User level library which maintains and tracks the threads. The kernel knows nothing about user level threads and manages them as if they were single threaded process. So whatever the threads are coming from the user level space, the kernel is managing those threads. And these concepts we find out in some of the concepts like POSIX threads, maxi threads and Solaris threads, which are implemented inside the operating system. So this is the example where user level threads will be created in a user space and kernel level threads will be created in a kernel space. And in a user space there is a library which will create the threads and maintains and tracks these threads. Advantages: thread switching does not require kernel mode privileges. So thread switching does not require the permission involved because it is done through the system calls. User level thread can run on any operating system. User level threads are fast to create and manage because it don't require the permission from the kernel, and the response will be fast and it will be created fast. Disadvantage is that in typical operating system most system calls are blocking. Okay, disadvantage can be some of the system calls can be blocked by the kernel due to some reasons. So there the blockages will be there for the user level threads. Therefore, user level threads requires a non-blocking system calls, that is multi-threaded kernel. So to solve this problem, the user level threads requires non-blocking system calls, that is a multi-threaded kernel, where the user thread will be handled by the kernel threads. Multi-threaded application cannot take advantage of multi-processing. Next is multi-threading models. So in operating system, multi-threading models can be implemented. So if you implement multi-threading models in the operating system, then there is a user level threads can interact with the kernel level threads. So there is an interaction between the user level threads with the kernel level threads. So because of this, the execution will be very fast and in an efficient manner. And in this concept, multi-threading concept, there is a non-blocking system calls. So because of this non-blocking system calls concept, execution will be in an efficient manner. So there are types inside it, that is many-to-one, one-to-one and many-to-many model. So first one will see many-to-one model. So many-to-one model means in the diagram you can see there are many user level model and a single kernel level model. So this many user level threads can be managed by a single kernel, So multiple threads cannot be run here at a time. Multiple threads cannot be run here in a parallel because only one thread can access the kernel, because at a time only one thread can access the kernel. So concurrently parallel, many threads cannot work here because kernel is accessing only one thread. So some of the systems where you can find out this concept is Solaris green threads or GNU portable threads, which can be implemented in the operating system. This is another diagram you can see. In user space, multiple threads can be generated with the help of thread library, which keeps all the track of threads and generation of the threads. And at a time, only one thread can be accessed by the kernel. Next, one-to-one model. So in this one-to-one model, at the user space, only one thread is generated, and for each thread, even kernel thread is generated. So each kernel level thread is managing each user level thread here. You can see here in this diagram also, in the user space, only one thread is generated and one thread is accessed by one single kernel thread. So this means that many threads can run in parallel on multiprocessors, and other threads can run when one thread makes a blocking system call. Next is many-to-many model. So in this diagram you can see there are many user level threads and there are many kernel level threads. So many user level threads will be accessed by the many kernel level threads. So it maps many of the user threads to a equal number or lesser kernel threads. The number of kernel threads depends on the application or machine, which type of application it is. So even in the diagram you can see multiple user level threads are generated and multiple kernel levels are generated, and multiple kernel level accesses multiple user level threads. Allows many user level threads to be mapped to many kernel threads. Allows the operating system to create a sufficient number of kernel threads, and this concept we can find out in the systems like Solaris 2, Windows NT 2000, etc. So here we have completed the concept of threads. In the next session we will come with new topic. Thank you.